In this video, we're going to look at molar mass and the mole. So during reactions, chemists need to know the number of atoms in a sample of a given mass so we can predict what is going to happen and how much product we're going to get out. But there's no way to actually count atoms because they're really small. So instead of talking about we have X number of atoms, chemists talk about we have X number of moles. So the mole is either spelled M-O-L-E or M-O-L. And this is really just a shorthand way to talk about a quantity of things, like a dozen or a gross is to a baker. Now, 1 mole is 6.022 times 10 to the 23 things. Now, chemists usually say they're atoms, but a mole can be anything. You can have a mole of elephants or a mole of grass. It's just anything. And this conversion factor is called Avogadro's number. And Avogadro was a scientist about 200 years ago. Now, how do we convert between mass and moles? So let's say we have a 35.423 gram sample of carbon. How many moles are in that sample? Well, to do that, we need a conversion factor. And lucky for us, the periodic table actually has our conversion factors. So the mass of 1 mole of atoms of any element is its molar mass, which is super convenient for us. So what does that actually mean? Well, the molar mass of carbon is 12.01 AMU, or it is also 12.01 grams per 1 mole. Therefore, with a periodic table, we can figure out how many moles are in a sample of anything as long as we know the molecular formula of our sample. So let's try and use this. So we have 2.02 moles of zinc. How many grams is that? And how many atoms is that? Pause the video, try to figure it out, and come back when you have an answer. Alright, so let's take a look at this. We're going to start with train tracks because this is dimensional analysis. Like I said in the previous video, we're going to use dimensional analysis a lot. So let's start with our given information. We have 2.02 moles of zinc. How about our conversion factor? Well, it's given in the periodic table, where 1 mole of zinc is equal to 65.38 grams of zinc. We multiply the top together, divide by the bottom. You see our moles cancel out, and our answer is 132 grams of zinc. Our answer has 3 sig figs because that's how many sig figs were given to us, and our units are grams of zinc. Okay. How about how many atoms are in this 2.02 moles of zinc? Again, we start with our given information, 2.02 moles of zinc. And our conversion factor is Avogadro's number. So 1 mole of zinc is 6.022 times 10 to the 23 atoms of zinc. And we get, in that sample, we have 1.22 times 10 to the 24 atoms of zinc. Again, look at our sig figs, 3 and 3. Look at our units, atoms, because moles cancel out. So we know we did our math right. So just one final thing to say about the mole. The lighter the atom, the lower the mass of 1 mole of atoms. And this is given again in the periodic table. So for aluminum, 1 mole is roughly 27 grams. Carbon, it's 12 grams. Helium, it's 4 grams. However, in the mole, you always have the same number of atoms. That is a constant. That's your conversion factor. That's Avogadro's number. So we can convert between grams and moles and number of atoms or back again using either the periodic table, the molar mass of the element, or Avogadro's number. Alright, that's it for this video, and see you in the next.